In this lesson, we're going to talk about perpendicular lines and how to solve algebraic problems using perpendicular lines. So first of all, remember the definition of perpendicular lines. It's when two lines intersect and they form right angles. So if you look at these two lines, they are intersecting and they're forming right angles. And whenever you have one right angle formed, you can go ahead and you can label the other three angles. So really all four are going to be right angles. And that's because if this angle right here is 90, well, these are vertical, so those both have to be 90. And these two angles are supplementary, so if one's 90, 180 minus 90 gives me 90. And then again, you could say because these are supplementary, or because you could say those are vertical angles. So all four are always going to be right angles as long as you know that one of the angles is a right angle when the lines intersect. Also notice that you don't necessarily have to have lines to be perpendicular. You could have segments, you could have rays to form that 90-degree angle. So it doesn't have to be two lines. So a couple of things I want to mention. The symbol for perpendicular, you've seen it, but I just want to make sure that you have it. So the symbol is it looks like an upside down T. And the reason for that is because it looks like right angles. It looks like you have two right angles here. So that's the symbol for perpendicular. And then when we talk about perpendicular lines and we're solving an algebraic problem, the conclusion that you're going to be using is you're going to say perpendicular lines imply that you have right angles, or perpendicular lines form right angles. But this is probably the shortest way. So perpendicular lines imply right angles. So that's going to help us solve some algebraic problems. So let's look at some different examples here. So the first ones are multiple choice, and it's just making some conclusions. So we're given this diagram below, and it says that angles 1 and 2 are congruent. So I'm going to go ahead and mark those. So these two angles are congruent. So which of the following statements is a conclusion which can be drawn? So 1 and 2 are right angles. So let's see for a second. If 1 and 2 are congruent, well, 1 and 2 also have to add up to 180. And if you have two angles that add to 180 and they have to be equal, well, if you divide 180 by 2, you get 90. So that really means each of these angles is 90 degrees since they are equal and they have to add up to 180. So that one's actually going to be true. We know that 1 and 2 are supplementary. That's true because they form a straight line, so they have to add up to 180. M is perpendicular to N, so line N is perpendicular to line M. Well, that's true if I have a right angle. If the two lines intersect and form a right angle, that means that they're perpendicular. So that means really all four of these are right angles. So that's true, so it's going to be all of the above. Example 2 starts off with saying that the two lines are perpendicular. So lines M and N are perpendicular, which remember means that this entire thing's a right angle and really all four of these are right angles. So I'm just going to leave the 1 and 2 as being marked so it doesn't look too confusing. So we have a big right angle here. That doesn't mean that angles 1 and 2 are equal. That would only be true if it said that AB was an angle bisector. Think about it. I could have angle 1 could be 50 and angle 2 could be 40 and they still add up to 90. So that doesn't mean, just because this is a right angle doesn't mean that those two have to be the same. So that one's not true. Angles 1 and 2 are complementary. So remember what complementary means? It means that the angles add to 90. So 1 and 2, well, if they form a right angle, they have to add to 90. So that one's going to be true. And then angle 2 is a right angle. No, angle 2 is not a right angle. Angle 2 is part of a right angle, not the whole thing. AB bisects the angle. Well, I said that 1 and 2 would be equal if this were a bisector, but it doesn't say that. You have to be told that you have a bisector, or you have to be told that the two parts are equal to make a bisector. So in this case, the only answer is going to be that they are complementary. So let's look at the next page. So for this one, we have A and B are perpendicular. So if you look, they already marked a right angle. And since the lines aren't fully drawn here, they're just two rays, you don't mark the other four angles because you only see one of the right angles. Find the value of x. Well, if this angle is a right angle, well, then that means the two parts have to add up to 90 because they are complementary. They form a right angle. So since we have a right angle, the angles are going to add to 90. So I'm just going to say that they're complementary. So complementary angles means that the angles add to 90. And that's because it's telling us that the lines are perpendicular. So then we can go ahead and set our equation up. So it's going to be 4x minus 8 plus 5x minus 10 equals 90. So combine like terms first. So 4x plus 5x is going to be 9x. And then minus 8 minus 10 will be minus 18 equals 90. So then bring the 18 over. So we have 9x equals 108. Divide by 9, you get x equals 12. And it doesn't say to plug in, it just says find x. If we look at the next example here, it says we're given straight lines A and B, and notice these little arrows here. That means that those lines are parallel. So I'm going to say these two lines, not A and B. A and B are just two lines that are intersecting. The arrows represent parallel, so I'm just going to mark that here. Let me put red arrows so that you know it's not the arrow heads, it's the arrows here that represent parallel. So since I have parallel lines, now you want to be thinking, okay, here's my two lines that are parallel. Here's my transversal. And you're thinking about your angles that you typically have. So like your congruent corresponding angles, congruent alternate exterior, congruent alternate interior, those types of angles. So here's my two lines. I just made that dotted for a minute because I want you to see here's the two parallel lines, here's the transversal. So if I'm looking at x, you can turn your paper if you need to, but you want to look at what kind of angle is x and 42. How do those relate? And the reason why I say 42 is because it's the only angle that's given to us. So how are these two related? So they're on the exterior and they're on alternate sides. So they're just going to be alternate exterior angles, which means they're congruent. So I have parallel lines, which implies congruent alternate exterior angles. So that tells me that x has to equal 42. So that's part A. Part B, you're trying to find y. So now if I look at my diagram, so if I ignore the yellow here, and I look at, so this is 42. And if I'm trying to find y, I notice that first of all, I have a right angle right here. That's marked. So I can easily find this other measure here because I know that 42 and this angle, they're complementary. They have to add up to 90. So I can go ahead and I can subtract. So 90 minus 42 will give me 48. So that means this angle's 48. And now what I see is I see this straight line. So I see that these two angles, this 48 and angle y, have to add up to 180 because they form a straight line. So this is because I had right angles, so let me write that first. So this was because complementary angles imply angles add to 90. That was the reason for that. And then my second reason is going to be angles that form a line implies that the angles add to 180. So that's going to be the second reason. So if I want to find y, y is going to equal 180 minus the 48. So y is going to equal 132. So that one was a little bit more intense because you had more parts to it. Let's look at the other two, which are more straightforward. So this one says we have straight lines M and N, and it has a marking here for perpendicular, which means you can go ahead and mark all four angles being perpendicular. So find the value of x. Well, it says this whole angle here is 3x plus 8. Well, that would have to equal 90 because it forms, because if this is a right angle, well then all four are right angles, which means that the degrees in this space here is going to be 90 degrees. So you can just set it equal. So 3x plus 8 equals 90. And then subtract 8. So we have 3x equals 82. Divide by 3. You get x equals, so you're going to see in the calculator 82 over 3. So you could leave it like that. Or you can get it as a decimal. And that's going to be x equals 27.3 repeating. And remember, to get the decimal, you hit Control Enter, and that'll give you the decimal. Now, my reason for this would just be to say perpendicular lines imply right angles. So since I have perpendicular lines, it means I have a right angle, which means I can set it equal to 90. And then the last one here, again, you have perpendicular lines. So if this part's labeled with a right angle, you know that the other part, and really all the parts down here, if this line were to continue, or this segment were to continue. But in this case, I only care about this right angle here. So I have these two angles are complementary because they're forming a right angle. So the sum of them has to equal 90. So again, my reason will be complementary angles implies that angles add to 90. So since it's two parts, they're complementary because they would have to add to 90. So I'm going to do 67 plus 2x minus 1 equals 90. Combine like terms here, so I have 2x plus 66 equals 90. So then bring over the 66. So we have 2x equals 24. Divide by 2, you get x equals 12. And that's it for that one.